Hello, this is Tyler Beamer, Haywood Community College. This is an instructional math video for DMA 040. This video is on the topic of Module 4, Section 4, dealing with the addition property of equality. So we're going to start solving equations using addition subtraction. Alright, so a little bit of vocabulary definition. An equation has the root word equals. So an equation has a algebraic expression set equal to another algebraic expression. So this is an example of an equation. We've got the expression x plus 7 set equal to the number 10. Equations come in all kinds of different formats. So you could have something like this. All right, that would be another example of an equation. But anytime you see the equal sign, that's when you know that you are working with an equation, not just an algebraic expression. Okay, so the whole goal of us solving equations is to find the value for x. Right? So what number, when I substitute into this equation for x, gives me a true statement. Right? A true statement being, I get the same value on the left side of the equal sign as I do the right. Okay, so that's what we're going for. So here's the difference. You can see equations have equal signs and expressions do not. So that's one of the big differences. So we're going to be looking at equations from here on out and how to solve. Alright, so we're going to use the addition property of equality. And the addition property of equality states that if I have two expressions that are equivalent, if I add the same value to both sides of the equation, then the equation remains true and the value on the left would be equal to the value on the right. And if I subtract the same amount from either side of the equation, the value would stay the same. So it's kind of like a scale. If you had a scale, alright, so this is my horrible attempt to draw a scale, right? Think about like kind of the scales of justice or whatever. So if I had the same amount on both sides of the scale, right, the scale would remain even, balanced, right? If I took one of the items away from one side, obviously one side would be heavier, right? So this would be heavier than this one. So in order for me to balance that back out, I would do the exact same thing to the other side. So I would just take the same amount away from the other side of the scale and it would be even again, be balanced again. So I don't know, that's just one analogy that you can kind of use to help you with this, but you always want to keep your equation balanced. Basically, whatever I do to one side of the equation, I need to do the exact same thing to the other side of the equation. So that's basically what this property of equality is stating. So here's an example of that, right? So I'm just going to rewrite this so you can see it a little better. So we're essentially trying to find the value for x that I can plug in here, and when I subtract 4 from that value, I get 7. That's the end game, right? And some of you guys may be thinking, well, I can just come up with that in my head. Well, that's great, right? But when we get to some of these more complicated equations, you may not be able to do that so easily. So it's good to get the algebraic skills needed, necessary to solve equations down to a good understanding, basically creating good habits. So, all right, so we are essentially trying to get to this statement. X equals some number, right? That's what we're looking for. We're looking for this, right? So in order for me to get to this x equals statement, I need to get rid of this minus 4. If I get rid of the minus 4 on this side, then that's going to allow me to just get x isolated on the left-hand side, right? And I can then solve for x. So to do that, I want to do the opposite, right? So we want to do the inverse, or opposite, of minus 4, because I want it to cancel. So the opposite of minus 4 would be plus 4. Right? Minus 4 plus 4 gives me 0. That cancels. Right? So these cancel, and that gives me x equals, right? And then here's where the adding property of equality comes into play. If I add 4 to the left to keep my equation balanced, I have to do the exact same thing to the right. So I do the exact same thing to the right hand side, and 7 plus 4 gives me 11. So now this is not unknown. Now I know that x equals 11. So this is what we would call a solution. So in order for this to be a solution, right, that means that I should be able to evaluate each expression on both sides of the equal sign and get a true statement. So if I plug 11 in for x, and I evaluate this, 11 minus 4 does indeed equal 7. 7 is equal to 7. That is a true statement. Therefore, this verifies that this is a solution. Right? So once I find a solution, then I can check that solution by plugging it back into the equation. And I'm looking for a true statement. If I get something that's not true, right, something false, like 6 equals 7, obviously that's not true. That would be a false statement. Then I would know that this number would not be the solution, that I would have the incorrect answer, and I need to find my mistake somewhere in my math to find the correct answer. Okay. All right. So here's one that's a little bit more involved. Okay. Notice I've got an expression on the left-hand side, expression on the right-hand side. Neither one of these expressions are simplified. So before we start the solving process, before I start using inverse operations, I need to simplify each side of the equation. So I'm going to basically cover this up. If I cover the right-hand side of this, that is an expression. We spent all of section 4 learning how to simplify that. So we want to simplify that left-hand side. So these are like terms. 6x minus 5x is 1x. So the left-hand side simplifies to x plus 8. Simplify the right-hand side. 8 minus 3 is 5. Right. So we want to do that before we start solving. And that makes the equation easier to solve. So now I'm ready to try to cancel the plus 8 out, right? That'll give me the x equals statement I'm looking for, so that'll isolate x. So the opposite of plus 8 is minus 8, so that's the inverse, and I do that to both sides to keep the equation balanced. 5 minus 8 is negative 3. Okay. Check that solution. So plug negative 3 in everywhere there is an x. Okay, so this gives me negative 18 plus 8 plus 15. So this gives me negative 10 plus 15, which is equal to 5. And of course 8 minus 3 is equal to 5. So we get a true statement. So this just verifies that this is indeed the correct answer. You do not have to do the checking part. If you're confident that you've done this correctly, your answer would be correct. However, when you're first starting to learn this, or if you're like on a test and you only have one chance at each question, it's good to be able to confirm that that's correct by checking it. All right. Here's another problem that we can simplify first, right? If I look at the left-hand side of that, I can distribute the 3 through the parentheses to simplify the left-hand side. And then that simplifies. The right-hand side cannot be simplified. So now I can start to solve. Now this one's a little bit different. I've got x's on both sides of the equal sign. So keep in mind that we want to always work to get that x equals statement, right? And when you solve equations, in most cases you have multiple ways in which you can solve them. However, there's always one most efficient way to solve the equation, and that's the route that you want to take. So in this particular example, right, this is a positive 9x. The opposite would be to subtract 9x. And if I do that to both sides, I end up getting negative 15 equals 1x, which is the same as x. And in one fell swoop, I have this equation solved. Okay. That would be the most efficient way to do the problem. Here's another way you could have solved the problem. Right. Let's say instead of subtracting 9x from both sides, I subtract 10x from both sides. So I get negative 1x minus 15 equals 0. So then I would have to continue to try to isolate x. I'd have to add 15. And then we're going to learn this in the next section, but in order to get rid of the negative 1, because this is negative 1 times x, I've got to divide by that number to both sides. And so that would then give me x equals negative 15. So notice that I got the same answer either way I solved this problem. However, this took me, after simplifying, this took me literally 1 step to solve. This took me 3 steps to solve. All right. This is much more efficient. So you always want to try to solve equations the most efficient way possible. I like to use the analogy, if I want to drive from Haywood Community College to Asheville, there's literally countless ways I could do that. If I wanted to, I could drive to California and then all the way back across the country to Asheville. I could drive to New York and to Asheville if I wanted to. Right? There are roads that would take me to both places. But people don't do that, right? People take I-40 east to Asheville from here because that is the quickest, most efficient way to get there, right? So when you solve these equations, always take the most efficient route to get to the answer. This is like driving on I-40 east, right? This is like, driving to Canada and then back to Asheville, right? Can I get from point A to point B? Sure, right? It's a lot longer process to do that, though. Okay, so just keep that in mind when you're solving these equations. All right. So we've got a lot of simplifying in this one here, right? I can see the like terms, 4p minus p. So 3p minus 11. I can see the like terms here, right? 2 and minus 20. So 2p minus 18. Okay. All right, and I've got multiple ways to approach solving from this point, right? You know, I could subtract 3p from both sides. I could add 11 to both sides. I could subtract 2p from both sides. I could add 18 to both sides. I got 4 options, right? What's the quickest, most efficient way to get to the answer? Well, I would recommend trying to get the 1p or p equals, right? Isolate p. So I would recommend doing that first. So if we subtract 2p from both sides, since this is a positive 2p, that's the inverse, that cancels. Do it to the other side to stay balanced. That gives me the positive 1p that I'm looking for. Okay. And then once I take that first step, it kind of dictates what the next step's going to be, right? So the next step in this case is to get rid of the minus 11. Right, so the opposite of that is plus 11. So I get p equals negative 7. So even though there were multiple approaches here, right, this is the quickest and easiest way. Could have taken another approach, but then that would have involved more steps to get to my answer. Okay. And then also note how I'm working these problems. I'm keeping my work organized. I'm showing every step, right? Being very diligent about writing everything out. And that way, if you do make a mistake, it's easier for you to find that mistake and then, of course, fix it. It just sets up good habits, good organization and skills, which will be very helpful later on when we get into solving some more intense equations. All right. So yet another example. We've got lots of simplifying on the left, right? Don't forget that there's a negative 1 that's in front right there that's not written. So we do distributive property twice. Distribute the 5 through. So that gives me 15 plus 5z. Then distribute the negative 1 through to give me negative 8z minus 9. And then I can continue to add like terms on this side, right? 15 minus 9, right? Those are like terms, so I can combine those, and I'm going to get a positive 6, 5z minus 8z, negative 3z. Okay. So negative 3z plus 6 is what the left side simplifies to. That equals negative 4z. Okay. And then, at this point, right after I simplified, I would want to use my inverse operation. So remember, always simplify first. Okay. If you start trying to do inverse operations from the get-go, it's going to get really confusing and it's not going to work out for you. Okay. Alright, so here's what I would recommend. Okay, this is kind of getting ahead of ourselves here, but I would do the inverse of the minus 3z to both sides. So that cancels. So 6 equals negative 1z. So I'm almost got the z equals statement except for this negative 1. So that's negative 1 times z. So the opposite of multiplication is division. I divide by this exact number that I have here. And when I divide by negative 1, that's just going to change the sign. So I get positive z equals negative 6. And that would be our solution. So in the next section, we're actually going to look at multiplying and dividing inverses. So this is kind of getting into that arena. So, all right. So we're going to be looking at solving equations for the next few sections. Like I said, work on starting good habits, right? Setting those for that when we get to the more complicated equations, things will be a little bit easier for you. All right. As always, if you have any questions, please email those to me. or stop by the office. Have a great day.